Hello everyone, good afternoon. Sorry for the technical issue, but it seems that my PowerPoint is not working with all computers, so sorry about that. My name is Ayse Balaban, and today I'm gonna present a work with a collaboration of Toygar University and University of Greenwich. So today I'm going to talk about a specific novel material and then the investigation of material properties of that sandwich material, which consists of carbon epoxy face sheets and PVC foam core. So I'm going to start with the introduction to the sandwich composite materials, which we are already familiar with it, but just to give like a background information, and then after that I'm going to talk about the motivation and the aim of the study, and after that I'm going to present the experimental testing procedures and what type of experiments that we ran, and then I'm going to present the results and discussions part with the conclusion of the work, and after that I'm going to talk about what is going to be the next steps. So as we know, the composite materials are getting quite popular, and especially for the sandwich composite materials are getting more popular every day because of their different usages in different industries, and also basically just by using the different lightweight core materials, we can improve the strength of the composite materials, and also we can change the application areas of the composite materials. So especially for the nowadays, the glass epoxy face sheets with different types of core materials, they are mostly used in mechanical engineering applications or marine applications, but nowadays, especially the aerospace engineering and the automotive engineering, they started to use the carbon epoxy face sheets with some PVC foam core. So that's why this is the motivation of our study actually. So we manufactured, we designed a composite material with different different thicknesses of the face sheets, and they are carbon epoxy face sheets, and we use the PVC foam core as the core material. So basically we chose to use different dimensions for each face sheets because basically the previous study that we were working on was a similar composite material, but with the e-glass fiber face sheets with the similar PVC foam core, and then depending on our results, basically we saw that the unsymmetrical materials might be used for different purposes. So that's why for this study we decided to go with the carbon fiber face sheets, but again with keeping the unsymmetrical composite materials for different purposes. So the sandwich composite materials, they were all manufactured in Evren, which is a composite company in Turkey, and then all the experiments that we ran, we completed in the UK. Okay, so basically this is the dimensions of our face sheets. So the upper face sheets is 3.75 millimeter, and then the PVC foam core was like 24.85 millimeter, and then 1.4 millimeter was the lower face sheet. So these are quite like specific numbers, but as I said before, there is like a preliminary research behind it, and then there is another. We started with the sandwich flat wise tension. It is quite important for us to investigate material properties for the sandwich material first. But in order for us to know, also we need to know the material properties of the foam, PVC foam and the face sheets individually, and then we need to know how the sandwich or how the components are behaving together under different types of loading. So this will give us an idea about the usage areas for the materials. So we started with the sandwich flat-wise tension for the and for the whole sandwich manufacturing, and the samples were quite small, so 50 millimeter per and 50 millimeter. So and the all the experiments they were run according to the ASTM standards, and then the loading speed was 1 millimeter per minute, and then after that we were able to calculate the ultimate stress values. And after that we did the sandwich flat-wise compression test. So for the compression test, again, it was according to the ASTM standards, and then again the loading was 1 millimeter per minute. And then after that, obviously, we ran the experiments depending on the loading size. So for instance, we loaded from the thicker face sheet side and or the thinner face sheet side. So surprisingly, the answers were not quite different than each other. So, but we completed in the both sides. And after that, as I said, we were not quite sure about the data sheet, but we just wanted to see if it is applicable, or after the epoxy, how it's gonna work, etc. So we ran the core flat-wise tension test as well. And the last experiment was the sandwich edgewise compression, as the normal face sheets are carrying the load generally. And then, so also half the buckling was going to was important for us in order to see the difference, or in order to see any kind of like delamination or any kind of like uncontact between the face sheets and PVC foam core. So we ran the sandwich edgewise compression test according to that, and then we calculated the maximum stress values. Okay, so for the results, according to these three experiments for the flat-wise tension and compression, and then the edgewise compression, so we calculated the maximum stress values and how much load, or what was the behavior of the materials depending on this. And then we calculated so for each experiment we ran the tests for 3 different specimens, and then the results were quite similar to each other. So that's why we took the average. And now for the sandwich flat-wise tension, for the average stress value was the 1.7, and now for the maximum ultimate compression value was the 6.7, and then for the for the maximum stress value was the 302.32. 2 minutes. Okay, I'm completed. Okay, so for the what did we learn? So actually the tests showed us that yes, we were quite right about our predictions, and as we were using the carbon epoxy face sheets this time, so obviously it was able to carry more load than the glass epoxy ones previously. And then, so for the, again, we were able to examine the behavior of the sandwich composite under specific loading conditions. And then also we saw that if we change the core material, so there might be some problems within the face sheets and then the core materials as well. So for the conclusion on future work, actually, yes, this was a good start for us to see the behavior of the basic failure modes of the sandwich composites, but of course this is a quite start for us. So we are going to run some flexural tests in order to understand the material behavior, and then we are going to run the tests for the both face sheets. So we are going to change the loading conditions, we are going to change the loading directions, and then after that there will be the fracture toughness experiments for mode 1 and mode 2 type, and then we are going to run some low velocity impact testing for this material, again from the different face sheet sites. Thank you very much for listening.
Time for perhaps a quick question. Okay, hearing none, thank you again.